Can everyone hear me again? Oh, perfect. All right, thank you so much, Becca. See, she remembers things that even I don't remember, which is both impressive and very scary. And I have to start this session out by saying that nobody warned me that I would be in the big room. So we're all in this together right now, I think. So thank you for coming to this session. My name's Meaghan Anderson. I'm an extension field agronomist with Iowa State University. Here's a nice map of the state, and there's actually 11 field agronomists across the state. So if you ever have questions that you need answered and you think maybe Iowa State University could help, all of you have an extension field agronomist in your area. I happen to serve this area 7 right in the center of the state. So I have an office here in Ames, and I live in Bondurant, and I serve 9 counties, but I have colleagues elsewhere in the state that serve the whole area. My background is primarily it's in agronomy, but in weed science. That's always been a topic of most interest to me, and so I was really happy that they asked me to come speak today on residual herbicides and cover crops, because I think if we want to implement cover crops across Iowa and elsewhere, we need to have a pretty good understanding of how the herbicides that we're using during the growing season in order to, maximize yield, reduce weed interference with the crops that we're growing for cash, how those interactions occur and how to minimize concerns with those. And so the outline for today, here's the 3 things that I want to cover, right? Residual herbicides reduce weed densities, competitiveness, and seed production, right? And we cannot separate weeds from cover crops if we're seeding cover crops during the growing season as well, right? So they can do the same thing to cover crops. So we need to be aware of how that works, and maybe that's how we can figure out how to minimize the concerns. Many factors are going to influence the risk that a herbicide poses to a cover crop, but most of those factors are going to be manageable, right? So until I can control the weather, I can't control everything, but I can control a lot of things in my fields. And finally, careful planning and reasonable expectations can help set us up for success with cover crops, and I think that's where we want to head, right? So here's a nice picture. This is a cover crop that we actually seeded during a relatively dry growing season, and you can see there that this cover crop, right, it germinated and emerged, but it is exhibiting some herbicide symptomology on it. So this was seeded intentionally to try to see what risk the herbicides pose to cover crops. So let's start this out with a little bit of a refresher on what residual herbicides do, why we use them, what their purpose is. So I think everyone's aware that herbicide resistance is a huge concern, right? We are putting a pressure on the weeds in the fields, and the weeds are succeeding at beating some of the herbicides that we use. And so that resistance has not eliminated the use or the benefit of herbicides in many of our row crop systems. What it's done is, in a lot of cases, it's increased the use of residuals, right? We are putting more residuals out in our fields. It's also increased the rates of the residual herbicides that we use, right? So we're trying to overcome some of this low-level resistance by increasing the rates. And that's a good thing. That's not a bad thing, right? In a lot of cases, if we were using cut rates, we need to be using full rates. The water hemp species in particular, and other amaranths, have extended emergence patterns. And those extended emergence patterns require the use of residuals if we are using herbicides to manage these weeds, because when we put a herbicide out there at the beginning of the growing season, and water hemp is going to continue emerging for maybe 8 to 10 weeks after that herbicide is applied, that means we need something that's going to last for a long time, because we cannot continually be out there managing it every time a new water hemp plant emerges. And so this extended emergence pattern makes water hemp much more challenging as a weed species than a lot of the other weeds that we deal with in Iowa. So the purpose of residual herbicides is that their intention is to provide several weeks of weed control, generally aimed at small-seeded broadleaves and grasses, right? So we're thinking things that have very small seeds. Those are going to be easier for most residual herbicides to control. And so oftentimes we're going to expect maybe about a month out of something that is a true residual herbicide for control, right? So I'd expect perhaps like 30 days, but maybe 2 to 6 weeks of control is a good window of expectation, just depending on what product we're using. And and what primarily the weather is afterward, and we'll talk about that. But some of the herbicides that we use have sufficient longevity to affect cover crop establishment, even if that cover crop establishment is happening months later, right? So even if we use this herbicide in April or early May, and we come back in August or September to seed our cover crop, we could see an effect from that herbicide. So this is just a very basic graph, but it's really important to understand, right? So herbicides degrade in the environment, right? As soon as a herbicide is applied, the degradation process starts for that herbicide. So on this graph, basically we're showing just a generic, the amount of herbicide remaining or percent of herbicide remaining over time. And so when you apply that herbicide, 100% of it is there, right? It's maybe not all available to be used at that very moment in time, but what happens is it immediately starts to degrade. And so in normal conditions, we expect that, you know, maybe this second month, right, when there's only half that amount of herbicide left or so, maybe that's when it stops affecting the weeds like water hemp. And this is important to understand because that degradation process changes a lot depending on what the conditions are, and we'll talk about that more in a little bit. Product persistence also varies. So the herbicides that we use are going to potentially persist less or persist more depending on what product it is. And so these are just a few examples that I want to point out. Some fairly commonly used herbicides in our system. So the first one is atrazine, right? It's used in corn primarily in Iowa, and it has a half-life of 60 days approximately. And so that half-life gives us an idea of how quickly it breaks down. So basically from whatever your full rate was that you applied, it maybe takes a couple months for that full rate to be reduced to half the original rate. So is it a concern for rotational crops? Yes, it definitely can be. But something like a dicamba product, maybe Banville, Clarity, or Extendamax, right, that could be used in corn, small grains, soybean. It has more of a shorter half-life, 2 to 12 weeks, right? So mostly it's going to be shorter than that 60-day time frame. And in most cases, due to a combination of the length of time it stays in the soil and the sensitivity of rotational crops, it's not going to be a concern, right? Especially when we think of the time of year when we're using those types of products, they just aren't going to be a big issue for rotational crops. Cobra is another one that's interesting. That one is not used as commonly in soybean anymore, right? But that would be a product that could be used over the top in a non-GMO soybean situation. So that's going to be applied a little later in the season than some of these other herbicides often are. And it has like a 4 to 6 week soil residual. And so that one is not going to be a concern for several reasons, one of which it doesn't have a very long soil residual to begin with. The second reason is that plants are not going to take that product up from the soil like they might take dicamba or atrazine up from the soil. And so that product just is not going to be a concern for us. Something like Pursuit, right? When we talk about soil residuals, this is one that has an extremely long soil residual and a potential for carryover in the right situation, even to a rotational crop like a year later, right? So this is something that's applied in soybean. It is much more likely to carry over in lighter type soils where it was used at a higher rate than suggested, right? So when we think of variation across fields, we can see issues with imazethapyr carrying over if we have kind of a sandier knoll or something in that field. And because of that long soil residual and the susceptibility of rotational crops, yes, that certainly could be a concern. So there are a lot of factors that influence risk. We've already touched on a few of them, but I want to highlight more focused what those are. And so there's a number of factors that influence the risk of carryover in general, whether it's to a cover crop or a rotational crop like corn or soybean, right? One of which is the herbicide product that we use and the rate at which we use it. Another is soil characteristics. There's absolutely certain soil characteristics, depending on the product, that will result in it lasting longer in the soil. Typically higher organic matter soils, products are going to hold on longer. Environmental considerations. What do we need to break down a lot of herbicides? Rain. Yeah, we got to have water, right? So if we are excessively dry, like some of us have been in recent years, that's certainly going to be a concern. And then rotational crop susceptibility. This is the big piece that I think we have a lot of opportunity to manage when it comes to cover crops, as well as the time between that application of the herbicide and when we seed that cover crop. Certainly there's going to be riskier scenarios and less risky scenarios. You can see here in this picture, right, in this case this is a soybean field, and this just has some very strange spot where herbicide was able to carry over. So oftentimes when I run into herbicide carryover, it's not on a field-wide basis. And that's something that I would expect to observe in a cover crop as well, right? Because of all the different factors that influence carryover risk, I wouldn't expect to see a field-wide failure of a stand based on just a herbicide. Perhaps that could happen. It would be extremely unusual to see, right? We expect that we are going to see certain areas within fields where we would have much more dramatic effect. So that soil and environment piece is hugely important, and we don't have quite as much control over that as perhaps we do like choosing a product or a rate of a herbicide that we're going to use. And so there's a lot of different factors that are going to influence the persistence of these chemistries. So soil type certainly is going to affect how much product is held in the soil and how quickly it's released. Soil organic matter, very similarly, right? Clay soils, high organic matter soils will hold on to chemistries for longer. It will be harder to release the herbicide from that soil. But oftentimes, that means it's going to last longer, but it will also be less available for plants to take up. Soil pH is another one. Certain chemistries are much more likely to carry over at high soil pHs, and some are more likely to carry over at low soil pHs. Atrazine is one that when we have high soil pH, we're more likely to see herbicide injury as a result of that. Finally, right, environmental considerations, rainfall, including both the amount of rainfall we get, but the timing of it as well, right? I think that rainfall during the growing season, shortly after application, makes a much larger difference than November rainfall does as far as herbicide degradation goes, right? It can help jumpstart that degradation process, which is not necessarily good for weed control if we get too much rain, but it means that it's going to be much less likely to carry over. And then, of course, temperature, right? So when we think of the big mechanisms of breakdown of herbicides in the soil, temperature is going to have a huge influence on those, or at least one of them. We'll talk about that. So that weather piece is important, right? I'm repeating kind of the same graph that I showed before, right? So that first breakdown of that herbicide is maybe an average rainfall scenario, right? That's what I'd expect in a quote normal year, or whatever that is anymore. But if we are dry, right, we are going to see less breakdown. It's going to slow down, and it's going to extend that breakdown process out. So instead of perhaps getting to that 50% or so mark after a couple months, right, it's maybe taking us twice or 3 times as long to get to that. So that herbicide is going to stick around longer and pose a greater risk. And the reason it poses a greater risk is because of the routes of herbicide degradation, right? Microbial decomposition, chemical, and photodecomposition. So photodecomposition is not hugely important for the great majority of chemicals that we use, right? At least as far as herbicides go. There are a few herbicides that are going to be dramatically influenced by sunlight or light, and those are typically going to be ones that require that you till them in. So trifluralin or treflan is an example of one that is going to photodecompose. Chemical decomposition and microbial decomposition are going to be two that are highly influenced by things like temperature and the amount of moisture availability. And these are going to be the primary mechanisms of herbicide breakdown in the soil. And so we can sort of connect the dots and see why that environment is going to play such a big role in whether or not something carries over, because the decomposition routes require, right, kind of like Goldilocks conditions, right, warm temperatures but not too hot, and I want enough rainfall but, you know, not too much sort of situation to degrade our herbicides. So have we been dry recently? Yeah, Yeah, we've been dry. So this is from December 15th. I figured it's a pretty good representation of what we look like across the Midwest as far as drought goes, right? We are quite dry. You can see particularly up here in northwest Iowa, if we're looking at Iowa, but then, you know, over in Nebraska, right, up into southern South Dakota, let's see where else, Kansas, right? We are very dry. This is important as far as herbicide breakdown goes, but I would argue that this time of year, it's not nearly as important as what happens during the growing season. Additionally, this is sort of an accumulation of soil profile depth, lack of moisture. Right, so what we can look at is sort of these more current soil moisture conditions. I could get those 0 to 100 updated map from January, but I couldn't get the next one I want to show you. So I'm going to show this comparison. So this is 0 to 100 centimeters, right, which is, I believe, about 25 inches, if my math is correct. And so you can see that the percent of moisture in this soil profile over here, really through kind of the western half of the state almost at that little angle, is somewhere between like 0 and 5% of what we would like it to be, right? 100 would be it's completely full, right? So we are very extremely dry. But as far as herbicides go, do you think the full 25 inches makes a big difference as far as degradation? Not really, right? Because when we are applying herbicides, we're applying them at the surface of the soil. They are going to get into the soil to an extent, right? And they will, you know, eventually have the potential to leach out of that soil. But really what we're worried about as far as herbicide carryover is what's happening in what we would call that root zone. And when it comes to cover crops, what I'm really worried about is what's happening in maybe the upper 4 to 6 inches of soil, right? Because that's where those germinating cover crops are going to be sticking down their first roots and either succeeding or, if there's a lot of herbicide carryover, potentially failing. And so they do offer this 20 centimeter, right? So more like 5 inches or so depth. And you can see that really for the majority of Iowa, at least at this point, right, December 15th, there was quite a bit of moisture available in a lot of our soil. So from a herbicide breakdown perspective, if this was looking at the growing season, I would maybe be less concerned than what the drought monitor is reflecting. Make sense? So again, like I said, this time of year doesn't make nearly the difference that it would have during the growing season, but that's something to be thinking about, right? Even though we are extremely dry, right? We are bone dry in some of those soils, right? What we're really worried about is what's happening real-time moisture-wise, right? Are we getting rainfall during the growing season in that upper part of the profile to help break down those herbicides? And so something that we can do during the growing season, if we are expecting that we're going to seed a cover crop, especially if we've been dry, or maybe if we've used one of these products that would traditionally be considered more risky, and we're going to talk about those, we can do what's called a herbicide bioassay. Relatively low effort, right? You can see here I picked up like a $2, what is it, like a sink, like a tub I'd put in the sink to wash my dishes in from Walmart. I drilled some holes in the bottom of it, and then I went and I collected representative soil samples from the field in which I plan to seed a cover crop. And so in this case, you could see that I have several different species seeded. I also seeded over here soybean and corn, just as kind of an indicator, right? Like if nothing grew, then I know there's something else wrong in that situation because at least one of those crops was growing already in the field where that herbicide was applied. But in this case, I went and I soil sampled using a soil probe to only 3 to 4 inches, right? Because what I'm worried about is that root zone where those plants are going to start establishing. And I went and I collected, right? That took a little bit of effort to collect that much soil to get in there, right? Mixed it all together thoroughly. You could do the same kind of concept with a spade or a trowel, right? Just make sure that you get a representative sample of the soil. You want to choose appropriate species to test, right? If you want to seed a cover crop, I would seed a cover crop, right? Whatever species you're looking at. But I would also make sure to maybe seed something that you would expect to be able to grow in that soil. And then once you've seeded it, allow it to grow in a nice, sunny, warm place for about a month, right? A lot of things will say 3 weeks, but I like to look at them for about a full 4 weeks, right? So I can allow them to come out of the ground, and what's most important to me is not what these cotyledons, those first leaves that come out, are doing, but I want to see that those next leaves are developing normally, like I expect them to grow in the field. All right, so this is just, it's not perfect, but it's kind of an easy, fairly low effort way to just check and see whether that carryover could be a concern, right? If I baby these plants along, are they going to die as a result of whatever herbicide was out there? So that's kind of the first step in this planning for success, but that's really more of a diagnostic thing, right? What can we do ahead of time to be planning to make sure that we're successful with our cover crops? And so I view it as sort of 2 ways, right? So you can plan your herbicide program around your cover crop, or you can plan your cover crop program around your herbicides, right? So some of this is going to depend on what your own personal feelings are, right? Are you really set on having a super successful cover crop, but maybe you're doing it in a clean field and you're not as worried about this really high level herbicide program that's going to be extremely effective against a broad spectrum of weeds? Or are you worried, like, if I don't do a good herbicide program, my water hemp is going to take over everything, and then my cover crop is never going to establish well anyway because I have such a thick cover of weeds out there, right? So we're maybe going to look at this as 2 different ways, and you're going to pick which one works the best for you, or perhaps a hybrid version of it. So when you're carefully considering your herbicide program, there's several things you can do. The first of which is look at your herbicide labels. Has anybody ever told you to do that? Surely not, right? The label's the law, and it also contains somewhat valuable information when it comes to planting cover crops, believe it or not. One of which is that you can check the labels for their rotational restriction section, because that will contain information on what crops were likely tested by the company that could be seeded in rotation with that herbicide. So that's a good way to look for indicator species that may be more tolerant to whatever herbicide you've used, or perhaps it will allow you to cross something off your list and say, whoa, canola, 18-month rotation to this herbicide, probably not a good idea to go seed canola or a rapeseed out in that field. Another thing you can do, right, as a part of that is looking for this time frame for establishment, right? If I look at these rotational restrictions and it says I can seed something in 30 days, well, heck, that's a pretty good option for me to seed, and maybe I could do something ingenuitive with it, right? I could do interseeding. But if it says, again, 9 months, right, 12 months, perhaps that's not the best option of a cover crop to try to go out there and interseed with. The other thing is to use good data, right? If you're planning your herbicide program, you should be planning it around the weed species that you have. What weed spectrum do you have? And in my mind, it should be field specific, right? Because you may have certain weed issues in one field that you don't have in another. And so paying attention to herbicide efficacy data, as well as things like the cover crop susceptibility and the herbicide programs that might be labeled for certain species, are going to help you pick programs that will hopefully balance the weed control and allowing a cover crop to establish, right? Some of the cover crop species that we have either are commercially produced crops elsewhere that have herbicides labeled for them, or they may even be, similar species to ones that have herbicide programs labeled for them. So think like field peas, right? If we're doing like an Austrian winter pea, that may be somewhat similar to a field pea as far as its tolerances go, right? Seed size is going to be similar. They're both legumes, and that may be someplace that I look to see, okay, are there certain herbicides that I could use maybe on a field pea that may also be tolerant, or that my Austrian winter pea may also be tolerant to. The first thing that you should be thinking about ahead of time, in my mind, before you plan your herbicides is, do I intend to harvest or graze my cover crop? This is something that I really don't like talking about because because nobody likes to hear that most herbicides are going to eliminate the ability of somebody to legally graze a cover crop, but it's something that has to be said if you're going to undergo that risk, right? So if you are going to harvest or graze your cover crop, right, the label's the law, so you're legally required to follow the label, rotational, and grazing restrictions for the herbicides that you use. If you do not intend to harvest or graze, right, that cover crop is never going to leave that field, whether it's in an animal or on a truck or however it would leave, you would just be assuming the risk of cover crop injury yourself, right? All that means is that if you're going to do something that the label doesn't allow, as long as it's not going to go and be consumed by anyone or anything, you're taking that risk on yourself, and you're not going to come back to the company and say, hey, your herbicide killed my 10 cover crop species that I seeded out here. And so these rotational restrictions are important. So this is just an example that I wanted to show, right? The time interval between this Halex GT application and replanting or planting of a rotational crop. And so these are going to be on every label. They're not always going to look this clear and pretty and outlined in a table like this, but rotational restrictions exist on every herbicide label. And so you can see here, right? Barley, oats, rye, and wheat, 4.5 months. So I could fall seed those in some cases, right? That gives me an idea that those crops are probably going to be more tolerant to whatever products are in Halex GT than maybe some of the other options that are out there. Down here, right, we can see canola. It has a 12-month rotation. That's probably less tolerant to Halex GT than some of those grass crop options. And then one of the other questions that people often ask, they say, well, my cattle, they really like turnips, right? Or they like radishes. Well, where do those show up on the herbicide label? The answer is they really don't, right? Because herbicide manufacturers are not going to pay to have every one of these herbicides tested against every potential crop that might be out there. And so what happens is many of the species that we use as cover crops end up in this all other rotational crops section where things are not necessarily tested, but they can say after 18 months after this herbicide is applied, you could probably plant anything and it wouldn't be a concern. And so that makes this cover crop thing especially challenging, because when we want to diversify our cover crops or seed earlier, right, we are just crunching everything in time frame wise, and we are making it a lot harder to select these chemistries. If we're seeding at a more typical time of year, right, say August or September, there's been a lot of really good research done looking at herbicide programs and even individual species impacts. And so I bring up this data all the time. It's from the University of Missouri. Kevin Bradley and some grad students of his did this research in 2013 to 2015, looking at basically full rate applications of selected herbicides in corn and soybean and their effect on a number of potential cover crop species. And so what they did is they went out, I believe it was in early June in Missouri, Columbia, Missouri, sprayed these herbicides, and then came back in, I believe, early September, and they drilled the cover crop species. And then they evaluated both stand loss and the effect on biomass, basically for a month after those plants germinated. And so I'm going to show you a table here. It's coded green, yellow, or red. And so that just gives you kind of a green light, right? Yellow is a little caution, right? Maybe one of the 3 years of research showed that it reduced the biomass or the stand or the stand of that cover crop. And then the red is 2 or more years that species was affected. Probably not a good choice in combination with that cover crop. And this is some of the best data that's out there. It's really hard to do this research. And so this is for soybeans. I just wanted to show you kind of some selected herbicides. And I ordered them by group number because I'm a weed scientist and I think we all need to know these group numbers, right? So group 14 products, those first 2 are used pre-emergent in soybean. They're going to be used basically before the soybeans emerge. That third one, Flex Star, right? That's going to be a common post-emergence product used in non-GMO soybeans. Sencor, right? That's a group 5 metribuzin product. First Rate is just an example of a group 2 ALS inhibitor. And then the group 15 products are products that are commonly sprayed over the top of soybeans with maybe an early post type program. And so what you can see here is you can look at it by herbicide and say, well, this metribuzin at 1/2 pound per acre, that wasn't so bad for a lot of different species. Maybe that's a product that I can use ahead of a later season seeding of a cover crop mix. Or I can look at it and I can say, all right, I really want to seed hairy vetch, right? Which of these herbicides that I might use in soybean are maybe going to be at reduced risk? And so he has more herbicides and more cover crops, but I kind of condensed it down to make it a little bit easier to consume. And so here's just the same kind of example with some different corn herbicides, just to show you. Right, same kind of thing. We can look at it by herbicide, or we can look at it by cover crop species, right? So over here you can see cereal rye, very tolerant to most of the corn herbicides. Crimson clover, not so tolerant. And so by doing this, we can say, okay, which herbicides might be riskier for use with cover crops? And some of these are going to be field specific or soil type specific, but atrazine, group 27 herbicides, the bleachers, clopyralid, and a group 15 product, pyroxasulfone in corn, and then followed in soybean, right? Fomesifin, that Flex Star product, right? We spray that post. That's going to be much riskier because of the later timing as well as the residual. Pyroxasulfone again, and acetochlor, those are both those group 15 products that can be sprayed post. And then possibly some of these ALS inhibiting products like chlorimuron and imazethapyr that are likely to carry over potentially even to corn. So also could be risky for soybean or for cover crops. So the alternative route is to plan for your cover crop. And so if I'm planning for my cover crop, I'm always trying to decide what are the species that are going to do the job that I want, right? They're going to provide me the benefit I expect. Can I find ones that are going to be less risky with the herbicide, less sensitive to the herbicides that I'm using? Generally, but not always, larger seeded species are going to be more tolerant to the herbicides that we've applied. Grasses are also, by and large, much more tolerant than a lot of the broadleaf species to the herbicides that we use. Many of the grass products that we use just don't have the long soil residual that some of our broadleaf products do. Grasses also, most of them have larger seeds. Later seeding dates, right, that's going to help with the ease of establishment, but it may present challenges for the variety of species. So it's all about balancing what your goals are. So as far as sensitivity goes, this is sort of the general sensitivity ratings that have come up. Much of this is from that data that Kevin Bradley accumulated from 2013 to 2015, looking at various growing seasons, right, different rainfall amounts, but some of it's from other things as well. But you can see down here this kind of winter pea, crimson clover are more sensitive, right, and we've got most of these grasses stacked up here at the top. So where do other species fit? That's always the big question, right? Because researchers have limited time, limited space, and limited money, right? We can't test every species that somebody may want to seed. So this is just another set of data. This was, again, primarily done by that group out of Missouri, but they looked at a number of different species and herbicide programs in general. And you can see that even the most affected species in these studies, right, this was 2 site years, for forage radish was the most affected. They only had about, let's see, somewhere between 10 and 12% ground cover reduction after 28 days. So there's a lot of, not a lot, there's, I would say, fairly significant research that shows that overall, if we're seeding at a typical timing in the fall, most herbicides that we use really are going to be fairly low risk, which is good news, I think. So earlier seeding increases risk. I know people are very interested in the interseeding and 60-inch rows, trying to get those cover crops in and maximize their growth as early as possible. We do have to remember that if we're doing that for grazing, right, that presents all those challenges of following herbicide labels. Right, that makes it extremely difficult, if not impossible, to do, at least legally following the labels. balancing your weed control and your cover crop establishment becomes much more challenging when you shorten that window up. I'm running out of time here, guys. All right, so how do we reduce our risk? One of the things would be to seed a little bit later, right? So seeding, a week after planting is probably going to be more challenging than seeding closer to V5 or V6 when that corn is getting closer to shading the row. That does present a challenge for some cover crops to get established, though. I understand that. Again, choosing those more tolerant broadleaves and grasses, or alternatively choosing a wide enough variety of species that hopefully at least something makes it through, right? So sort of like the principle of seeding some of the CRP, right? That you maybe have 30 or 40 species, knowing that perhaps not every species is going to come up, right? That's a little extravagant for a cover crop mix, 30 to 40 species. But again, the principle, right? Maybe you pick 10 species, knowing that maybe in part of the field, you're only going to get 5 or 6 species. Focusing on a good burn down herbicide with a low rate of residual early, and then following that by a residual after your cover crop has emerged is probably one of the best and perhaps only ways to really get a cover crop established and reduce the weed pressure concerns, right? And those residuals, again, we have to focus on those lower risk residuals for carryover, the ones with the shorter half-lives, but we also want to make sure we're targeting whatever our most common weeds are. Other opportunities, there's probably many opportunities. Farmers are incredibly adept at figuring this out, right? They're moving much faster than researchers can in a lot of their fields. So relying on some of the folks in your areas that have already tried these things and maybe found some success, I think is hugely important and something that I would be remiss if I didn't mention. So in summary, again, residual herbicides, they do persist in soil, right? That's their purpose. And that can affect cover crops, just like it affects our weed species. Shorter that window is, the more effect it has the potential to have. Many factors are going to influence that potential risk, right? Soil type, the rate of the herbicide we apply. Lots of these are manageable, right? The only thing I can't control is the environment. Careful planning, reasonable expectations are going to be what helps set us up for success, right? So maybe every cover crop species isn't going to work on your farm, but perhaps most of them do. I do have some resources here, right? I'm pretty much done, right? But some resources that can help you with this kind of risk analysis and planning. There's really good guides that provide herbicide efficacy ratings where you can look at the spectrum of weed species you have. Ohio, Indiana, Illinois, and Missouri weed guide. That's available for either download or you can purchase a printed copy online. The same with the Nebraska Guide for Weed Disease and Insect Management. I have a few copies of our herbicide use guide up here for cover crops. And then I also have a few copies of these Penn State publications, which talk about individual herbicide products and what species they may be more risky for. Okay. All right. Thank you all. I can put this back up, but I just want to say that I am here today, but you have representation all across the state in our field agronomists, and we're all here to help.
All right, let's give Meaghan a round of applause here for that excellent presentation. Thank you. All right, while folks are starting to formulate their own questions, I've got a couple just to kick us off here. So this fall, I heard of quite a few instances of people having issues with cover crop establishment in general. So can you just remind us like what it would look like if it's an herbicide that's inhibiting that growth there for the cover crop?
Oh, that's such a good question.
Can you repeat it too? Sorry.
Yes, right. So Becca asked a very intelligent question, right? People have establishment problems with cover crops all the time, especially this year, especially in some of our drier areas of the state. What would it look like if it's a herbicide that's inhibiting its growth, the cover crop's growth, versus something else? And so one thing that I think of is something that I mentioned, right? That it's typically not even across an entire field. If you have a herbicide that kills a cover crop that you're trying to establish across a whole field, I would be fairly suspicious that that was actually something else going on, right? Perhaps germinated and died due to dry conditions, or just kind of poor seed, or something else was going on. Typically, not always, but in most cases, your cover crop will germinate, right? So if it's on the surface of the soil, you'll see that root start to come out. Occasionally it will die right away, but if that root touches the soil, typically what I expect to see is some type of symptomology, right? So I do need to be watching that cover crop fairly closely during that kind of establishment time frame, maybe the first few weeks of its growth, in order to see that. And a lot of times what I'll see is that those cover crops, they'll germinate, they'll start growing, maybe they have some discoloration. Yellowing is really common. And oftentimes they just sort of stall out. They don't really grow very much, right? They're maybe a couple inches tall, and they just kind of stop growing and just sort of stay small and stunted like that. It's pretty rare, fairly rare, for wide swaths of cover crop to be completely killed off from a herbicide. Usually I can find symptoms.
Okay, excellent. We've got a question from online, and just if you've got a question, go ahead and raise your hand and I'll run the mic up to you so we can ask Meaghan of that. And Meaghan, I know that you've done some research on this. So the question from the live stream is, if a residual product is applied over a roller crimped or a standing cover crop, for example, cereal or rye, is there any tangible effect for covers holding on to that product and delaying its breakdown, its degradation? Or can you just tell us a little bit about like that risk of?
Yeah, so that's a very good question. Right, we apply the residual products in the spring. If we are coming off of another cover crop season, right, we're thinking soybean, maybe we've roller crimped it, or perhaps it's still standing and our residual herbicide is included with our burn down of that cover crop. What is happening to that residual herbicide when we apply it? Couple different things, right? So if the cover crop is dead or like already in the process of dying, say it's already been roller crimped, right? Starting to wilt down, it's not alive anymore. That product is probably not being absorbed into that plant tissue in any sort of substantial amount. Just a very good question, right? So what happens is that if that cover crop's not getting, or if the herbicide's not getting absorbed into the cover crop, it's going to kind of sit there on that cover crop tissue until a rainfall comes, and the rain will wash it off and into the soil, and then we sort of continue with the process that we expect, similar to how it would on any other type of crop residue. Now, if that cover crop is alive or partially alive, when we're spraying it, that cover crop isn't going to discern between, well, this is maybe the glyphosate that's here to kill me, versus this is the residual herbicide that if I absorb this, it's not going to do anything to me. And so what happens is that living cover crop tissue will absorb that herbicide. The big question is, when, if ever, is it released? And so there's some new research that is not published yet, to my knowledge, that maybe throws this into question a little bit, but there was some good data, again, from Kevin Bradley's group in Missouri, that showed that that cover crop held on to that herbicide, perhaps broke it down, right? We don't really know exactly what happens to it. It could be shuttled into a vacuole in a cell, and it could be there, right, in the same form it was when it was absorbed. But it could also be broken down. But what they did, the only thing that they could tell from that research is that it was never released in the 30 or 60 days after that application happened, right? Most of it was held on to by that green tissue, which can present a challenge for both weed control that spring, and it could present a challenge if it's held on to and potentially released far later. Whether that happens, I don't know.
So I've got a follow-up question to that. If we're hoping to get a good weed control from our residual product, and we've already got a cover crop out there in the spring, how late is too late to be applying that residual if we've got, I don't know, 2 feet of cover crop growth out there, cereal rye out there? That's
the $1 million question, right? At what point are we maybe wasting our money on a residual if we have that cover crop out there and it's got some size to it, right? That's the question, kind of.
Yeah.
Yeah, so I think based on that data out of Missouri, Kevin Bradley sort of came up with the rule of thumb that if it's more than 12 inches or so tall, it would have been better to either apply that residual earlier when that cover crop was closer to the ground and maybe there was more ground cover visible that you could contact with that herbicide, or wait and come back more in like an early post type application with a residual herbicide. Because that cover crop itself, if you've got a really good solid stand of a cover crop, you're going to be getting some weed suppression out of it. And I liken it kind of to a short-lived residual herbicide, right? Like we are suppressing small-seeded weeds for a short time after we've killed that cover crop because it's providing that kind of barrier on the soil. The challenge is that like in a perfect world, your cover crop is perfectly even across the field, right? You've got no open gaps. The weeds are all going to be equally affected by that cover, but that's not how reality works. And so I think in many cases, we're still going to want that residual herbicide, but we need to realize that that herbicide is covering us in gaps, and the rye or whatever cover crop biomass is probably doing the bulk of the work of the weed suppression where it's heavy. Everyone follow that? Okay. So like, right, in a perfect world, we'd have perfectly even cover of a cover crop that's all suppressing all the weeds in the field evenly, but that's not how it works, right? A lot of times we have gaps in the stand, or for whatever reason, the cover crop didn't germinate as well. And so I think in most cases, we still need that residual out there to protect us from those areas where weeds are going to come up through that cover or lack of cover. And so I think we probably still need it in many fields, right? Scout ahead of time, right? Decide for yourselves whether you think you need it. But we have to realize that when we use that herbicide, if we're spraying it on pretty tall, heavy cover green rye, it's probably not, most of it's not getting to the soil. And so our weed suppression that we're getting early, where we have really tall rye, is more so probably coming from that cover than it is from the herbicide itself, right? But that herbicide is protecting us in that, you know, spot where the drill operator went wide in the fall and left an open spot for the water hemp to emerge, or whatever species you want to pick.
Totally. So yeah, still applying that residual or just being willing to spot spray in those areas. But we've got another question here as well.
Yeah. Thank you. Are there any old herbicides no longer in use that have longer half-lives that we need to worry about that could still be persistent in the soil?
So are there any old herbicides no longer in use that we need to worry about from a half-life perspective that can still be persistent? So are you talking herbicides that have been used maybe in your field that people aren't using anymore? Yeah. No, I don't think so, right? The longest, some of the longer soil residuals and the more sensitive species happen coming out of like small grains and then going to crops like sugar beet up north, and even those, they typically only have like a 3-year rotation restriction on some of those. And so I'm not, for what we've used here in Iowa, it will have been decades since we've maybe used something that would have a carryover potential that would be that substantial.
Excellent. We've got another question over here.
Yeah, spraying a residual on V4 corn and then going to interseeded covers. How do you do that?
Yeah, spraying a residual on like V4 corn and then doing interseeded covers. So you want to interseed them basically at that same time, kind of?
Pre-emerge.
Yep. Yeah, so spraying the residual pre-emerge and then doing maybe a V4 type seeding in that corn. I think it can work. We need to be cautious about what species of cover crops we're choosing. And I think we probably need to use a lower, you have to be willing to use a lower rate of herbicide. But in corn, most of our pre's are going to heavily rely on those group 15 products, acetochlor, metolachlor, or potentially pyroxasulfone. Pyroxasulfone is that one, Zidua is the commercial name for it. That one is the one that poses the biggest risk. But I think people have found some success with lower rates of either the acetochlor or the metolachlor. It can be species specific though.
If you want to transition a traditional corn soy rotation production field into either grazing land or food quality crops, how do you determine the length of time, the residual? If a cocktail of herbicides have been used, is it based on whichever herbicide has the longest rotational problem?
That's a fantastic question, right? So if you're going to try and transition a piece of ground that has been corn or soybean into something more for grazing or haying, in either case, you'll need to know the herbicides. I would probably check the herbicides that were used in the last 2 growing seasons, and it would be whatever one has the longest rotation to that probably all other crops category. Most of them that we use in corn and soybean are going to be 18 months. There will be some that if it doesn't specifically list, like alfalfa maybe, or whatever grass species, hay species you want to seed, there's a handful of them that may have a 30-month rotation on them. But that rotation is to seeding of the rotational crop, right? So that would be to the point at which you can seed your hay. So yeah, most labels are going to have alfalfa on them though. So if you're looking at going to a hay crop and you want to do alfalfa, you just need to check those labels. Most of them will have it listed and will have a certain specific number of months.
I've got a question about something you said earlier about the plant absorbing the herbicide. So let's say you do a post in your corn crop and come fall you graze that stalk field with cattle. Is that stalk still absorbed? Is that chemical still in that stalk, or is that nothing to worry about at that point?
Great question. So say you spray a herbicide over your corn and during the growing season, and you're going to come back and you're going to graze those stalks later in the season. Is the herbicide still in the stalk? Probably, depending on the product, some of the herbicide will still be there. The good news is that basically for any herbicide that's labeled for use in corn, you can reference that label and it will have a grazing specific restriction on it for corn, right? So it might say 60 days or 30 days, or it may be 10 days after application. You just have to check the label to be sure of what it is. So that means, you know, if they put that specific timing right, that means that they have proven, basically, in order to put that on the label, they've proven that it's not going to be harmful at whatever level it may be at.
Okay, great. It sounds like it goes back to reading your herbicide labels over and over again.
Isn't that always the answer, right? The label's the law. Read your herbicide label.
Yeah. Do we have any other questions? Otherwise, oh, we've got one more. I think this will be our last one.
How does tillage after harvest affect chemical breakdown if you happen to be dry or whatever?
Yeah, great question. How does tillage after harvest affect chemical breakdown? Maybe somewhat product specific, but I think some of the research that is best has said that it doesn't necessarily improve or I guess lessen chemical breakdown, right? It doesn't really help it one way or another. What you get is you're perhaps diluting it, right? So if you are tilling your soil deeper than the depth at which that chemical was initially, right? If it was 6 inches deep in the soil and you're tilling to 8 inches, you're diluting that chemistry some. Yeah, it would help, but it doesn't necessarily break it down anymore.
All right, I think we're at time here, so let's give Meaghan one more big round of applause for her excellent presentation here.